Welcome to another podcast with Mr. Bohannon. Today we're going to be talking about heat capacity. Before we get started, let's take a quick look at our state standards. We're going to be using SPS 7, and it says students will relate transformations and flow of energy within a system. We're going to look at B and C specifically. B says that we're going to investigate molecular motion as it relates to thermal energy changes in terms of conduction, convection, and radiation. The C part of this says that we're going to determine the heat capacity of a substance using mass, specific heat, and temperature. Let's quickly examine some phases of matter and phase changes. I have omitted plasmas here due to us not being able to use an everyday example with it. So we have solids, liquids, and gases. Notice how the atoms are acting in each case. There are forces that hold the atoms together as well as forces that hold molecules together. These are electrically charged particles and they are said to have internal energy. Here's a quick example. Imagine that we have a glass of ice. The ice is a solid, therefore the water molecules are packed tightly together. They can vibrate, but they cannot move around. Well, let's add some hot water to the glass. What happens? If you said the ice starts to melt, you're right. The faster moving water molecules hit the tightly packed ice molecules. Energy is exchanged or transferred. Ice begins to melt. We therefore have a phase change from a solid to a liquid. When these internal energies transfer, the result is called heat or thermal energy. Now what would happen if we left the glass of water out? Well, if you said that the ice would eventually melt all the way and the glass of water would assume the same temperature as the outside air, you're right. The measure of heat is temperature, and this transfer always occurs between areas of high energy to low energy. Again, the measure of heat is temperature. This transfer always occurs between areas of high energy to low energy. So let's take a look at heat capacity. If you've ever been around anyone who's cooked, you know that metal pots heat up and cool down fairly quickly. Water, on the other hand, heats up and cools down slowly compared to the metal pots. We can say that water has a higher heat capacity than the metal pots. Every substance has a different ability to absorb heat from the world around them. This is called specific heat. Heat capacity is the number of joules required to raise 1 gram of a substance 1 degree Celsius. The formula for heat energy is stated this way. Heat, whether it's gained or lost, is equal to the products of mass in kilograms times specific heat capacity times the change in the temperature. Let's try a heat capacity problem. An iron statue has a mass of 0.75 of a kilogram and changes from a temperature of 20 degrees Celsius to 25.2 degrees Celsius. How much energy did it gain? Please note that the table is included with this problem and lists various substances and their specific heat capacity in joules per kilogram Celsius. The first step for solving problems is to go through and underline the important information in the problem. We have the mass number and the temperature change in the problem. Also, the problem stated energy gain, so we know that we will have a positive answer. Step 2 in our process is to write the specific heat formula, and that is Q equals M times C times delta T, which is change in temperature. You may often see this formula with a CP instead of C. The Georgia End of Course Test formula sheet uses the C, so we'll use that as well. Step 3 has us plugging in our information into the formula. As you can see, I wrote out mass 0.75 kilograms. The heat capacity of iron is 450 joules per kilogram Celsius. I got this from the table. and the change in the temperature is equal to the final temperature minus the initial temperature. You can do this in one long formula, but I find this to be very helpful. So now we have Q equals 0.75 kilograms times 450 joules per kilogram Celsius times 5.2 degrees Celsius. Step 4 has us multiplying our numbers together, and we write down our product. But something doesn't look right here, does it? Oh yeah, we need to find our units. Off to step 5. Step 5 has us writing down our correct units. The kilograms cross out, and so does the Celsius. That leaves us with joules. Remember, the heat capacity is measured in joules. Here are a few notes about these types of problems. First, you may have to rearrange the formula. You may be asked to solve for temperature, specific heat, or mass. Second, watch your units. This may include converting grams to kilograms, Fahrenheit to Celsius, or kilojoules to joules. Finally, check your work. If you have to change anything around, you still have the original formula. Plug your answer that you got for your variable and see if it works. Let's finish up our podcast by talking briefly about how heat transfers. There are 3 common methods. They are conduction, convection, and radiation. Well, let's go back to our water example. This time we're going to boil it on a stove. The first method we're going to talk about is conduction. The heat is transferred from the flame to the glass teapot and finally into the water. Note that this is the transference of thermal energy through touching. Next we have convection. The warm water rises and the colder water sinks. Now a lava lamp is a great way to look at convection. We've got globs of goo that are sitting on the bottom, and they gradually warm up. As they get warm, they start floating up the column. As they float towards the surface, they kind of stop at the top and they begin to cool off. And as they cool off, they begin to drop down at the bottom. And thus our little cycle starts again. This is a great example of convection. As we return back to the teapot, we walk up to it and extend out our hands. We feel the warmth radiating out from the pot. If you think about it, I'm sure you can think of a few other radiation examples yourself, like walking up to a warm fireplace or putting your hand up to a pot on the stove. I hope you've enjoyed this podcast, and I hope it's helped you learn about heat capacity and how heat is transferred. If you have any questions, please feel free to visit me on the web at www.bohannon.edublogs.org. Have a great day.